My name is Caitlin Didier, and this is a numerical calculation to show the potential difference between two locations near a dipole, but they are not on the dipole axis. They're just near a dipole. So on the first line, I just define the area, the width and the height of where this is taking place. UFPES is just the constant K, 9 times 10 to the 9th, that we frequently use in the electric field equation. S we made very small because it's the distance between the two dipoles. If we made it too big, then this probably wouldn't work. QD is the charge. So now we have to define the source charges. We have two of them, S1 and S2. S1, as you can see here, we made positive. S2 we made negative. So the red source charge is going to be positive and the blue source charge is going to be negative. They have the same radius, as you can see here, and the only difference is that in the X direction, the positive red source charge is in the negative S/2 direction, and the S2 source charge, which actually has a negative charge, it's the blue one, is going in the positive S/2 X direction. So the sources are S1 and S2 that we just defined. So now we have to define the path. Path A is going to be a vector 0.02, 0.020, and path B is going to be a vector 0.12, 0.080. So they're both only in the X and Y direction. We don't fool with the Z direction here. But as you can see, vector B is going to be a little bit longer and farther. It goes over in the X direction a little bit more and up in the Y direction a little bit more, but everything is positive here. So it goes from A to B. So when we take the potential difference, we're going to do B minus A because it's final minus initial. So now we're just defining that the path is going to be green, and so the initial potential for A and B is going to be 0, and so this is just defining all of the equations and getting the equations together, and this last line will actually print what we want to see, which is the dipole and those differences, VB minus VA, and we'll print the actual number. So if we run this, we should be able to see that. Okay, so there's the red dipole, the blue dipole, and we know that one is obviously positive and one is obviously negative. That's what makes a dipole. And we said that the red was positive and the blue was negative, and you can zoom in and zoom out on this just for your liking, but if you press out of the box that I defined, you can scroll down and see here what we printed, as well as VA. The potential at position A is negative 157.8 if you round, and the potential at point B is negative 7.2. So if we take the potential difference of these 2 points, VB minus VA, we get 150. So just by looking at the picture, we can determine that just by common sense, VB obviously has to be this position over here, which is farther away from the dipole, because it's going to have a lower potential, and VA over here is going to have a higher potential, being closer to this dipole.